Okay, hello everyone. All right. So today we will continue with the transistor, right? So yesterday we already finished about diode. Okay. So today we're gonna continue with the transistor. Okay, so I told you yesterday, right? Actually, the semiconductor P and N, okay, semiconductor type P and semiconductor type N, okay, is used to make electrical parts, right? Such as transistor and also diode, right? So diode, uh, we combine the N type with the P type, then you got diode. Okay, but let's say in the transistor, okay. So in the transistor, actually there are three parts that you need to combine. Okay, P and P. Okay, so there are two types of transistor, PNP and NPN. So mean if PNP means semiconductor type P combined with N and then combined with P. Okay, if NPN means semiconductor N type combined with P type and also N type. Alright. So it depends. Okay, so we're gonna learn about how to use, okay, what is a function or how to use a transistor as a current amplifier. Alright, so the transistor is an electronic component which has three terminals. Okay, so it has emitter, okay, it has a base, and also it has a collector here. Okay, so you can see in the diagram here, there are two parts, right? Two types of transistor. Okay, so this is the collector, this is the emitter, and this is the base. Okay, so the transistor is an electronic device that functions as an amplifier and automatic switch. So the transistor can be used, okay, to amplify, right, to amplify the sound, and also can be used as the switch. Okay, so this is the example, okay, the example of the transistor. Right. So this is in Malay, but I just explain it in English, right? So it says here the amplifier can make the voice of the singer, okay, become louder, right? So the amplifier system must have the microphone, amplifier, and also the speaker. Okay, and also at night, right? So you must be wondering, right, why when suddenly they at night they sound always like 7 p.m. or 6 p.m., right? Suddenly the road lamp will light up. Okay, and then later at 7 a.m., okay, in the morning it will be switched off. Okay, so actually there's no one control the lamp, right? There's no one control the lamp. It's actually the transistor. Okay, so the transistor, and they have another one that we call it as the uh perintah pekerjaya. Okay, wait, I forgot that the name is in English. Okay, we have a PPC, and also no. Thermistor is for the heat, right? For the light, I forgot. They said we will see next part. Sorry. Okay, so describe a transistor in terms of its terminal. Okay, so first you need to know the structure of the NPN transistor. Okay, so this is the collector, base, and emitter, right? So actually the important part in the transistor is the base. Okay, the base is control the amount of current flow through it. Okay, whether it can amplify, okay, how much that it can amplify the sound, or how does it control the current that flows, like act as a switch. It depend on the base here. Okay, so this one control. So whatever it is, the base is the important part. Okay, so this is the NPN transistor. Okay, the difference is the arrow here, right? For the NPN it going down, but for the PNP it goes up. Okay, so you need to remember uh, the uh, the arrow lah, means which one is going down, we call it as the NPN, going up is PNP. Okay, the arrow in the symbol, so what does it mean by the arrow in the symbol? It shows the direction of the current from B to E. So mean from the base to the emitter, right? If the symbol, let's say this one, the arrow in the symbol shows the current of the direction of the current from E to B. Okay, means from the emitter to the base. But let's say for this one, all right, for the NPN is from base to emitter. Okay. Alright, so now we have to name and state the function of the three terminal of transistor. So of course there will be a function and also the terminal. So for the emitter, right, the function is actually to emit the charge carrier. Okay, so this one it just emits, means it just give the charge carrier. Okay, base, okay, or B is control the charge carrier. So mean it control the amount. Okay, how much the charge carrier will be flow to the collector. And the collector, okay, is just collect the charge carriers. Okay, so emitter, it emits the charge carrier, base the one that control how much amount that the charge carrier will flows. Okay, and the collector is to collect the charge carrier. What does the arrow on the emitter in the symbol of transistor indicate? Okay, so what does the arrow mean? Is meaning the direction of the current. So it means this one, the current flows from the base to the emitter, right? NPN. So if P and P, okay, it goes up, means the emitter, the current flows from the emitter to the base. Alright, describe a transistor in terms of its terminal. So diagram shows a basic circuit for NPN transistor. Okay, so I put it here, NPN. Okay, this is the basic circuit. NPN. Okay, so it says here name two current pass through the transistor. Okay, so there are two current, there is a base circuit and also the collector circuit. Okay, this one. Okay, this one, the current will flows to base and also to the collector circuit. So there are two circuit here, means this is the base circuit, this is the collector circuit. Okay, this is for the base circuit, this is for the collector circuit. All right, so there are two current, means the current will flows through here, okay, through this one, or maybe or another one is through this one. Okay, positive to the negative lah usually, right? Okay, so the direction of the current is like this. Okay, so there are two type of circuit inside the if you want to use a transistor, you need to have two type of circuit, base circuit and the collector circuit. Right, so the base circuit, of course, the battery will be connected to the base, right, and also for the collector circuit, it has the positive terminal have to be connected to the collector. Okay, so name three types of current passing through a transistor. So what current flows through the transistor? Okay, so we focus on the transistor here. Okay, so the first type of current is the base current, the collector current, and also the emitter current. Alright, so compare the three current. Write an equation to relate the three current. Okay, so IE is bigger than IC and bigger than IB. Why IE is the biggest one? Because this one, it emits the charge carrier. Okay, it's the one that will emit the charge carrier. So of course, it will have the higher current here. Okay, while the collector is just collect the charge, right, that being received. Okay, you just only receive the charge carrier, but the base, right, the base is the smallest one. Okay, even let's say you just increase, right, the small amount of current, okay, the base will amplify it, right, to like maybe like sometimes 10-50 times like that. Okay, so the base is actually is the important part, but then it has the smallest current. Why? Even like if only like let's say if small current also, it can amplify it to a bigger one, right? So that's why he is the lowest current. Okay, why IE is the biggest one, I just told you, because he's the one that will emits the charges. So me, of course, he has a lot of charge lah. Okay, here. Okay, what is the function of the resistance R1 and R2 in the above circuits? Okay, R1 is to limit the base current. Okay, so this, because this one, the current will flow from positive to here, right? So it will go to the base. Okay, so when they goes to the base, right, what happened here? Okay, so they need to limit. Remember I said, right, even the small changes in the base current, okay, even the small changes in the base current, it can increase the current a lot, right? So that's why we need to have the resistor, okay? So it can control, okay? It can control the current flows, okay? So this is the base current. This is a function of the R1. Okay, then your R2. Okay, so R2, what's the function of the R2? R2 is an output such as bulb or motor. Okay, so this one you can change it to bulb or motor. Okay, the important part you need to put the resistor, okay, to the base part, because this one it will control the current that flows. We cannot make the current flows too much to the base current, because this one it will amplify, right? Small changes can amplify the base current. So then later your output, okay, let's say your bulb, okay, can be broken, right? Okay, then your IE is equals to IC plus IB. That of course lah. Okay, let's say I give the IE 2 ampere, okay, the currents. Okay, so that let's say this is 1.5, this is, sorry, yeah, 2 ampere. Let's say E is 2 ampere, IE is 2 ampere, IE is a 2 ampere, and then your IC, let's say, is 1.5 ampere, okay, and plus, let's say, B, the current at base is 0.5 ampere. So if you calculate it, it's the same, right? So this two one, if you these two, let's say the current at base and the current at collector, when you add it together, you will get the same amount of the current that flows at IE. Okay. Okay. So remember we discussed about the junction yesterday, right? The PN junction, the the voltage junction, okay? So there are two PN junction, okay? Because in diode they only have one, right? P and N, they combine P and N, so they got only one junction, okay? If diode it is like this, right? Example P and this one is N. So they got only one junction. Okay, but this one transistor, we combine three semiconductor, right? So NPN, PNP, so mean they have two PN junction, right? They have two PN junction, two PN junction, one and two. Okay, so let's see for the first part, right? So at the BE junction, okay, the emitter and the base, right? So this is the emitter. So the emitter is made from N type, okay? And the base is made from the P type, right? So here, from here, positive, right, goes to positive. Remember, P type is a positive, right? So positive to positive. So it will become forward bias, right? It will become forward bias, right? And then BC, okay? It's not complete yet. Okay, then BC junction, the base collector. Okay, that one the latest now is BE, right? Here is BE, forward bias. Okay, how about B to C? Okay, B to C, you can see here is a negative, right? N type. This one is a positive. So positive meet with the negative. What will happen? Reverse bias. Okay, so remember, right? At the base type, at the base, right? At the base, there must be always forward bias. Okay, at the base must be forward bias. So for E to B, there must be a forward bias. So it has to be connected to the positive terminal of battery. Okay, while B to C, it has to be reverse bias. So the N type should be connected to the positive terminal. Okay, so one BE junction, alright, forward bias, so P type positive terminal. Okay, and then this one reverse bias, so the N type have to be positive terminal. Okay, so there are two type of PN junction. That's this one, the first one, and the second one. Okay. Oops. Okay. Then the next part, all right? So this is the complete circuit. Teacher, do I need to remember the circuit? Yes, you need to know the circuit. You need to know the arrangement, right? So because sometimes in paper one, all right, they will ask you, okay, they will ask you which how you know how which one is the correct arrangement for the transistor, okay, in the circuit. So you have to know lah. This one have to be connected to what terminal. This is actually depend on the type of the terminal. Okay, sorry, the type of transistor. If P and P, then it's different. Okay, this one is NPN. Okay, so this is R2, as usually we already know is a resistor as the output here. Okay, and the R1 is actually the resistance to limit, all right, the base current. Okay, to control the amount of current that flows through the base. Okay, right? So this is the input and this is the output. Because the output you see it connected to the to the resistor here, and you already know the R2 here is actually the output. You can just replace it with bar, okay, or maybe something let's say for bell, okay, siren, so it's up to you, right? Okay, so the next part is said here, IB is equals to 0, IC is not, IC also must be 0 because IB control IC. Like I told you just now, whatever it is, in the important part in the transistor is the middle part, the base type, the base one. So the base is control the collector here, the current here. So if there is no current flows, there is no current flows to the base, that means at the collector also there will be no current flows through it. Okay, there will be no current flows through it. Okay, so whatever the part is base. Okay, so you have to make sure the base, okay, must have the forward bias so that the current can flows. Okay, this one is a reverse bias. Okay, so this is, okay, I already explained about this one. Okay, this one also teacher already explained, right? And then this one you have to know is start from positive to the negative. This is the collector circuit base. Okay, and this one is the base circuit, right? And has to be connected with because it's positive, this is NPN, right? So P have to be connected to the positive terminal to form a reverse bias, forward bias. Okay, notes. Okay, BE junction, this one we already discussed. BE junction have to be forward. BC has to be reverse bias. Okay, so when switch S is open, open means the current is not flowing. Okay, the current is not flowing. Please don't be confused with the word open and close. Okay, so when the question state the switch is open means the current is not flowing. If the switch is closed, then the currents flow. Okay, so when the switch is open means there is no current flows. All right, so of course the base current is 0. Okay, and IC is actually depend on IB, right? So when it depend on IB, okay, when it depend on IB, so when IB 0, IC also will become 0, right? Okay, and then the next part is, it says here, when a switch is closed, right? So when it closed, it mean the current can flows, right? Okay, the current can flows. Okay, so when the current can flows, right? So the electron will cross the BE junction. Okay, so the current will cross BE junction. Okay, BE junction here. All right. Then it fills in the holes in the base. Okay, they fill the in holes in the base. So because this one is NPN, right? So means P positive mean they got more holes than electron, right? So electron will cross the BE junction and fill the holes in the base because P is a positive, right? So means they have more holes than electron. If N means they have more electron than holes. Okay, so for this one, it has more holes. So mean the electron will fill the holes in the base here. Okay, then they move to the positive terminal of the battery. Okay, so most of the electron from emitter, okay, will attract to the collector through base. Okay, because so most of the electron from emitter here will attract to the collector through base because the base is thin, so as a few hole can be filled by electron. Okay, base is thin means this the junction is thin, so I mean it can fill the electron can fill the electron can fill the holes here. Okay, and the collector voltage is bigger than base voltage. Okay, so this collector voltage is bigger than base voltage. Voltage are not current, all right? So majority of the electrons are pulled to the collector. Okay, because this one have larger voltage, all right? This one has larger voltage, so the current will flows, okay? The electron will flows to the collector, right? So this is actually the explanation. Okay, yeah, the question is not that detailed actually. Okay, you just need to know how to set up the diagram. Okay, the diagram of the circuit. Okay, what should be connected to the base. Okay, and what is connected to the base mean whether it's a positive or negative terminal, and also you need to know like where is a forward bias and where is reverse bias. Okay, so that's the explanation. Okay, so this is the diagram. Okay, maybe this one might be much clearer. Okay, so positive goes here. Okay, so this is a BE junction. Okay, so you know they got holes here, right? So the electron will move. Yeah, I know that the current flows from positive to the negative, but the electron move in the other way. Okay, it move to the other way. So it will be negative to positive. Okay, all right. Okay, then after that, right, so they fill the hole, the electron will fill the holes here. Okay, and the electron will, yeah, I know positive negative, right, but this one the negative, the electron move in the opposite way, right? So the electron move here, then it goes to E, then it fills the base here. Okay, and also you know that the voltage at the collector is much bigger. Okay, so it will attract more electrons to the current. So you can to current to the collector, because you can see here they got three batteries, right? So mean the three batteries mean the voltage here is higher. So this one the voltage is higher. Okay, the voltage is higher, right? Okay, describe a transistor in terms of its terminal. Draw a basic circuit for PNP transistor. That one before this we learned about NPN. Now we are looking for PNP. Okay, so how we want to set up the circuit for the PNP transistor. Okay, so this is the circuit. Right. So you can see the difference, right? Okay. So this one, this one have this because the middle is at the base is N type. Okay, so you have to connect it with the negative. Okay. So that's why I said at the BE junction, they have to be the forward bias. Okay. While here, they have to be the reverse bias. Okay, this one must be forward bias, and at the collector must be reverse bias. So you can see the positive connected to the negative. Okay, so positive will be connected to the negative, right? And this is the diagram. This is only the same one actually. Okay, And again, you can see the current voltage, right? The voltage, right? The voltage for the base right here is, and then compare with the voltage of the collector here, right? So this one have more voltage. So that's why it can attract more electrons to flow to it. Okay. So because the number of the battery here, you see there is like three battery. This one is only one. Okay. Okay, next. Okay, to study the use of current transistor as a current amplifier. So how we use a transistor as a current amplifier? So the first one, observe the brightness of the bulb when the switch is open. Of course, when the switch is open, there is no current flows. Okay, lights off, right? Lights off. Okay, lights off. Okay, but the base current, okay, the circuit is not complete. Okay, we see for the base one. Okay, the circuit is not complete because you didn't switch it on. Okay, so because the circuit is not complete, is not switched on, the transistor is turned off. Because in order for the transistor to turn on, the current must flow through IB. If there is no current through IB, means the transistor will switch off. In order to make the transistor switch on, okay, you need to have the IB must have current that flows through it. Okay, so now the circuit not complete for IB, but the transistor is not turned on. Yes, correct. So the IB is zero because there's no current. So when there's no current, of course the collector current also will be zero. Okay, because IC is a depend on IB. Okay. Next, this is when the switch is open. So when the switch is switched on, mean it closed, right? Oops, sorry. Okay. So you can see here, lights on dim. Okay, at the base current. Okay, base current here, the light on dim. Okay, so why? Because the resistance B is high resistance. Okay, remember why we need to put this one the high resistance? I told you just now. Okay, the base current, they only need a small current. If you the small current also, if you let's say you increase a little current only, okay, 0.01, okay, the amount of the collector current that will collect the current from the IB will be larger. Okay. All right. So that's why they need to put the RB has a high resistance. So it can control the amount of current. Okay. It has to be very small. All right. And then let's say for the bulb at L2 here. Okay. So at L2 here, the sorry, L2 collector circuit here, right? Okay, collector current here. All right, you can see, okay, here the lights on brightly. Why? Okay, because here the collector current is larger than compared to IB. Okay, even they say 1 ampere. Okay, example, let's say 1 ampere flows to IB. Okay, here, all right, they will be amplified. That's why we said it's amplified. Amplified means make the currents bigger. So amplified, let's say 1, then they amplified it into 4 ampere. So that's why we much brighter here because of the current. Okay, so that's why the function of the current amplifier. So the current amplifier basically is amplified at the base here. Okay, so that's why I said the base is the important part. Okay, all right. So that's what happened when the S is switched on. Okay, what is the requirement for the transistor to switch on? Right. So the requirement is actually is a there must be a current flows through the base. Right. It must be a current flows through the base. Okay, the minimum one to turn on the collector circuit. Okay, and a base voltage must exceed a junction voltage about 0.7. Okay, so the base voltage must be higher than 0.7 because you know junction voltage is what? Junction voltage, okay, you cannot, all right, for the for the junction voltage, you need to be the current, the voltage need to be higher, okay, need to be higher so it can turn on, right? Then the electron can move, okay, the electron can move to PNP or P type macam tu, the current, the voltage must be higher so it can overcome the junction voltage. Junction voltage is actually at the P and the junction there, okay, right? Okay, next, compare base current and collector current. So IC is bigger than IB. In a transistor, the base current switches on the collector current. Okay, in a transistor, the base current, transistor in the base current switch on the collector current. So the base current will switch on the collector currents. All right. So anything is must be the base, right? So I will stop until until we finish at the current amplifier. So after that, for the automatic switch, this one we discuss tomorrow, okay? Because I don't want too many things, way too many info. Later you forgot, okay? Okay, next, if there is no base current, there is no collector current, all right? Of course, when IB is zero, IC also zero, okay? Base current IB control the collector currents IC. Yes, the base current control the collector current. That's why I said the base current is the important part. Okay, so a small change in base current, even you increase a small change in the base current, the result will produce the big change in the collector current. Okay, so that's why you need to have a resistor, okay, at the base circuit, because uh, it can control the amount that current flows. All right. Okay, next one. Okay, so this one can become the automatic switch, and this one can become the amplifier. Okay, so if you want to make the transistor as the switch, you must measure the IB is zero, right? Okay, your IB is zero. Then the IC also will be zero, then the transistor will switch off. Okay, that means there is no current will flows through the bulb, right? Okay, then let's say if you want to make it as the amplifier, you just increase the current that flows through the base, right? So when you increase the current at the base, okay, the current at the collector also will become bigger, right? Okay, so that is how we use the function here lah. Okay, generally. So later we will learn detail. Okay, how does the transistor use as the switch? Okay, this one is only as an amplifier. So you need to know the difference of the arrangement of the circuit for the amplifier and also for the switch, because for the switch you need another electric component. Okay, you need to have another electric component. Okay, and for heat also you need another electric component, okay, to detect heat. Okay, so that one we will discuss tomorrow. Right, so I think I will stop until now. Okay, so let's say if you have any question, you can ask me. Okay, so have a tomorrow night also I have a class. Okay, so see you tomorrow night. Okay, take care everyone. Bye. Welcome.
Thank you, teacher.
Welcome.